Be able to sketch something like this very quickly, just following each of the processes that we used for each part of it. Okay? And so I'm going to talk through one, have you do the next one on your own here. Okay? So when you look at something like this that has both a multiplier in front of the x, which is going to affect the period, it also has things being added and subtracted inside to the x, which affects the phase shift. Hey, what you're going to do is you're going to rewrite it in a factored form. So what you're going to do is you're going to take this given equation, 6 times the sine of, you're going to remove as a common factor whatever's being multiplied in front of the x. So if you remove a pi over 4, you're going to be left with x plus what? 5. Good. And then the plus 4 on the outside. So once you put it into this form, you now use all the different variations that we did from before. So what I would first do is select my horizontal or my line tool. My midline is going to be at 4, so I'm going to draw that in. Okay, I'm then going to look at my shift. My shift is what? 5 units to the left. So here's where my shift goes, to right here. If I use my amplitude of 6, I go up 6 for maximum. I go down 6 for my minimum. So I know where my max and mins are going to be. Okay? And so the last thing I need to do is calculate my total period. So the period is 2 pi divided by whatever multiplier is in front of the x, which in this case is pi over 4. Dividing by a fraction is like multiplying by its reciprocal. So the pi's cancel. 2 times 4 is 8. So my period is 8. So what that means is from this point here, where my horizontal shift occurred, my phase shift of -5, I need to move how many units to the right of the origin to get my total period 8? A total of 3 more, right? So this gives me my total period of 8. So from -5, or here from 3 to -5, represents one phase, okay, one period. And so if I cut that in half, right here, that cut each of those in half, here and here, I can now set up and solve or plot my points. So I'm then going to select my sine function, which is this tool, and I'm going to start. My sine begins at the midline, so here. Then it goes maximum. Since this is a positive number, it's going to be my max up here, then my midline, then my minimum, then my midline. And so when I sketch that, I get my rough sketch of one period of this. And to identify it, you're going to start at your midline, select an extreme point, in this case the maximum, and that is going to be your graph. So approaching this problem, again, I would select the line tool, draw my midline first. My midline is +3. I'm going to move up and down the amplitude, which is absolute value of -4. So I'm going to go up 4, down 4. So there's my max and min. I'm then going to rewrite my function by factoring out what's in front of my x. So pi over 2 leaves me x minus what? The 3. So what I can see is my phase shift is +3. So I'm moving over 3. Right? And so if I calculate my total period is 2 pi divided by whatever multipliers in front of my x. Pi over 2, which is like multiplying by the reciprocal 2 over pi. Pi's cancel. I get my period to be 4. So if I move from this 3, where do I have to go to complete one full period? A total of 4, so I just have to go over to -1, right? So what I'm going to do is cut that in half, cut each of those halves in half, so there's my critical points. And so since I'm completing one full phase here, right, this is a cosine function, so my normal phase starts max, midline, min, but there's a negative in front, so where's my first point going to start? Going to start at the minimum, and then midline, and then maximum, then midline, and then minimum. So this is what my sketch is going to look like of one period of this function. Okay, and so I'll use the cosine tool, and because I'm choosing from max to min, I can choose here to here, and that will complete my sketch for me.